Lesson 80 is called Using a Constant Factor to Solve Ratio Problems. Allow me to begin with some review. If I want to turn 1/2 into fourths, I know you don't really have to think about this anymore, but once upon a time, to figure that out, how would I get from 1 to whatever this question mark is? You probably think, what times 2 gives me 4? Use that to multiply by 1. Obviously, the answer is 2. So multiply by 2 to the top, and you get 2. This 2 we could call a constant factor. It stays consistent between the top and the bottom, and it's a factor because we're multiplying by it. Try a little bit bigger number. 1/4 is how many 20ths? Well, what times 4 is 20? 5 times 4 is 20. So I use the 5 on top. 5 is my constant factor. Another way we've shown this is doing 1/4 times, and then like in a box, I've shown that, and then where we're trying to go. And we figured that, well, 4 times 5, and this has to match top and bottom. This is a constant factor. 1 times 5 is 5, is how we would get to this. Since we need that, even though it's not lowest terms, we need it in 20ths. So we're going to do the same math today, but when we're solving ratio problems. Sometimes if your parents buy like a solution to wash your car, it might say something like mix 2 parts water to 1 part solution. It creates a ratio for you to properly dilute it so it's not super strong, but they can sell it so it doesn't take up as much room. It's a little easier if you just sell the concentrated solution and then you mix it with water when you get home. Or when you're making Kool-Aid, maybe more likely in your life, you probably mix like 1 pack to 10 parts water because the pack is so concentrated. A 1 to 10 ratio of Kool-Aid to water makes a pretty tasty drink. How about to make green paint, the ratio of blue to yellow is 3 to 1. I can also show that as a fraction. 3 to 1. Or to 2, I'm sorry, 3 to 2. So that's the ratio. It's the lowest terms version. How about now I've got 6 ounces of yellow paint. How much blue do I need? So you keep the same order. You can build a chart like this one and label it ratio, actual, blue, yellow to make sure you don't get this screwed up. And I've got my 3 and I've got my 2 and I've got my 6. You see, start to see how this reminds us of the fractions where we would go 3 over 2 is what over 6, right? 2 times what is 6? 3 is our constant factor. So 3 times 3 is 9. Boom, you just did the entire lesson. If you've ever thought about it with the 1/2 to fourths we were doing, another way to do it, it would always have been to do 4 divided by 2, the new denominator divided by the old denominator, which is, of course, 2. And this is your constant factor. Times 1 is 2. So when the numbers get just a tad bigger and scarier, remember you can just divide the number you know by its ratio number to get the top number, right? So first of all, little spelling mistake I see here. They're missing a space, aren't they? right here. I just want to beat you to it. Right here. Okay, 2 to 5, flowers to weeds. If there's 30 flowers, make sure that matches up with the 2. Don't put it on the bottom. How many weeds? All right, a little bit bigger numbers this time, so let's use what I just taught you. 30 divided by 2. This time it's not a denominator, it's the numerator that we know. 30 divided by 2. 2 goes into 3 one time, and 2 goes into 10. 5 times 15. You maybe even had that in your head. 15 is not the answer. 15 is the constant factor that we multiply by to get to, just like it's shown here. 5 times 15 is 75. Another way to think of it, if we go back to what we know, if I'm going from 2/5 and then I've got a numerator of 30ths, what times 30, or what times 2 is 30? 15 times 2 we said, or we divided to find that. 15 times 2 is 30, so you have to also multiply 15 by 5, and in your calculator you'd find that's 75. So this can be reduced back down to 2 over 5, but that doesn't help us when we're thinking about flowers to weeds in the garden is 2 to 5 simplified, but there's 30 flowers, so how many weeds is that? 75 is the actual count for weeds. So one really important thing is going to be keeping these straight. Flowers to weeds, 2 to 5. 30 is flowers, so it goes on top. Maybe you're getting me. If not, read through this, take some more time. It does want you to draw the ratio box. If you need it, do it. If you don't, don't. But do whatever you need. Make sure you're using a constant factor, maybe even writing it out, to solve ratio problems. Letter A, ratio of boys to girls in the cafeteria was 6 to 5. If there were 60 girls, how many boys were there? So here's the question. Girls, and we don't know boys. Which one's on the top? Which one's on the bottom? You follow the order. Boys to girls, 6 to 5. So boys is the one we don't know. Girls, because girls came second. Girls 60 is on the bottom. So you find a constant factor here that you're then going to use to multiply by the 6 to find the missing top number. So I got you started on letter A, and then try letter B. You'll be showing me answers for 2 lesson practice.